Welcome all. In this lecture, we are discussing about R and RC triggering circuits of SCR. So let us consider a simple thyristor circuit. In here, this thyristor is used to control the voltage across this load. So it is series, simply a series switch. So when this switch is on, this voltage, the input voltage is a sine wave. This sine wave will be appeared across the load. And when the switch is off means it is an open circuit, there is no voltage across this load. So here the Vs input source voltage is Vm sin omega t, means simply a sine wave with maximum value Vm. Okay, the maximum value is Vm. So let us analyze this circuit. So when the thyristor is off, this is the equivalent circuit. It is an open circuit. It is off, means no current is flowing through this, and the load voltage is 0. This point is not connected here because it is open circuit. So the load voltage is 0. So if you are considering here, the output voltage will be 0 when the thyristor is off. So what we are doing is, up to this point we are keeping the thyristor in off position, means we are not giving any gate pulse. So when the gate pulse is 0, the output voltage, the thyristor is in off state. Now the output voltage is 0 up to this point, since thyristor is in off state according to this equivalent circuit. So at this point, at omega t or t equal to this value, we are giving the gate pulse and the thyristor will get turned on. Okay. So when the thyristor is getting turned on, it is an equivalent to a short circuit. Okay. So now this voltage, this point will be connected here. So the V0 is same as Vs, means from this point onwards. So we are giving the gate pulse at this point. Okay, at this point. So from this point up to this point, the output voltage is 0, since it is thyristor is in off state. So from this point, output voltage become Vs, since the thyristor is turned on when we are giving the gate pulse. So it is same as Vs. So output voltage is same as this. Okay, so it will be like this. Okay, and in negative half, thyristor is in reverse bias condition. Even though we are giving the gate pulse, it will not conduct. So this is the condition. So again, about the voltage across this thyristor VAK. So when the thyristor is in off state, it is in off state means this point is here and this point is here. So means the VAK is same as Vs. Okay, and when the thyristor is on means this is short. So this point is connected to this point. Okay, so there is no potential difference between these points. So VAK is 0. Okay, so when thyristor is off, VAK is Vs. When thyristor is on, VAK is 0. That is, VAK means the voltage across thyristor. So up to this point, between these points, in this region, thyristor is in off state. So this is the condition. And from this to this point, thyristor is in on state. So VAK is 0. So we can draw like this. Okay, only at this period, this and this period, thyristor is on. So VAK is 0. Rest here, here and here, thyristor is off. So VAK is Vs, same as Vs. Okay. So we analyzed a simple thyristor based circuit. Okay. So here we told that we are giving the gate pulse at this point. Okay. So in order to provide the gate pulse, we need a circuit that is called triggering circuit. Okay. So or firing circuit. So first there are the many methods. First, so this is the thing. This is the circuit. So in order to give the gate pulse, we told that we have to give the gate pulse, then only thyristor will turn on. So in order to give the gate pulse, there are many circuits. It's called triggering circuit or firing circuit. So first type is R triggering circuit. Okay, R firing circuit or R triggering circuit. The process is called triggering. We are providing the gate, means that process is called triggering the circuit, triggering the SCR or firing the SCR. Okay, so the circuit used to trigger or fire is called triggering circuit of the SCR. The first one is R triggering circuit. So here this circuit is the R triggering circuit. This is actually the power circuit. Okay, this is the power circuit in which we are controlling the power using power electronics device thyristor. Okay, so this is the called control circuit. This circuit is only for giving the gate, so it is called triggering circuit. So here we are using two resistors, that is so it is called R triggering circuit. So we can now analyze this circuit. So during positive half, this diode, this point will be positive and this point will be negative. So here it is positive. So diode become forward biased. So initially thyristor is off state. So this is inactive. This portion of circuit is inactive. Only this is active, and this compared to this resistors, this load resistance is very small, negligible. Okay, and during positive half, diode is forward biased. So the equivalent circuit become like this. Okay, D is closed. Diode forward bias means it is conducting, to say short circuit. So if you are looking here, it is simply a potential divider circuit. This total Vs is now getting divided by R1 and R2, across R1 and R2. And R2 the voltage across R2 is taken as the gate voltage. Okay, this voltage is used to trigger the gate voltage. So let us analyze what is that voltage. So this is a potential divider circuit. Input is Vs. So the voltage across this R2 is Vg is equal to total voltage Vs and the resistance R2, where we are finding the voltage, divided by total resistance R1 plus R2. Okay, so that is the potential divider circuit, and this is the voltage across R2. Vg is, that voltage is same as the gate voltage. Vg equal to Vs into R2 by R1 plus R2. But Vs is nothing but Vm sin omega t. Okay, sine wave with the maximum value Vm. So the so it is the this is the Vs. Okay, so this is Vs, and it is only during the positive half. Negative half, this diode is reverse biased, no current is flowing, Vg is 0. Okay, so during positive half, Vg, the voltage across the gate, or the gate voltage is this much, means it is a sine wave which is having a magnitude Vm into R2 by R1 plus R2. So it is like this. Okay, it is a magnitude only in positive half, because D is conducting only in positive half. In negative half, it is the current is 0. It is reverse bias, it is not conducting. Okay, so the during positive half, we are getting the gate voltage as this, where this magnitude is Vm into R2 by R1 plus R2. Okay, this is the magnitude. So this voltage is giving to the gate, not to gate. So we told that this we have to trigger after some time, or we have to control that angle, fire. It is called firing angle. Okay, so we have to fire at this point, etc., etc. Okay, so we have to control this, means we have to apply the gate only at a particular angle. Okay, so we can analyze how it is achieved. Okay, using this R triggering circuit. So this is the shape of Vg, where the amplitude is Vm into R2 by R1 plus R2. So obviously it is depending upon this resistor value. So if R1 is made as variable, we can vary this, means we can vary the amplitude. So by varying R1, we can change this amplitudes like this. Okay, if R1 is increased, this amplitude get decreased. Okay, so it will be decreasing. Okay, okay, so it is varied by using this R1. Okay, so let us say this is the threshold voltage, threshold gate voltage, means when the gate voltage become this voltage VTH, it will become triggered, thyristor become turned on. Okay, so we the gate voltage should be at this point. Okay, then only the thyristor will be triggered. Okay. So here at this point, this gate voltage Vg is less than this threshold voltage, it will not be turned on. So at this point, the gate voltage become equal to threshold voltage. So at this point, it will be turned on, means we are triggering at this point. Then suppose we are again increasing R1. Okay, so amplitude will be decreasing. So what happened? It is getting equal only at this point. So alpha is increased, firing angle is increased, means firing is delayed up to this point. Okay, again we are increasing R1. So what will happen? Again amplitude get decreased. So it will be equal only at this point. So, means we can vary the firing angle. Okay, from up to this point to this point. Okay, so again if you are increasing, means it will become equal at 90 degree. Okay, so we can only increase up to this point. Beyond we cannot increase. If you are decreasing means it will not be turned on. Okay, so we can vary from 0 to 90 degree. See, here it is at this point. If you are increasing, it will be time will be delayed again at this point and this point. So maximum is alpha is 90 degree. So this is the working of R triggering circuit. So again, if we are triggering means output voltage will be V0 and this conduction will be through this. Up to this point Vg will be there. So after conduction there is no current through this. So Vg is 0. Okay, so this is the R triggering circuit, and only the defect is we can control the alpha between 0 to 90 only. So next is RC triggering circuit. Okay, so here we are using a RC network, and now we can analyze this circuit. So during negative half, here it will be negative and will be positive. Negative half. So negative half means here it will be negative. So diode become conducting. Diode become forward biased and will conduct. Okay, and we can neglect this load resistance and say this will be open circuit initially because it is not turned on. So the circuit is equivalent to this. This is short. So Vs is directly connected to capacitor. So a capacitor is directly connected to AC source. So what will then the Vs? This is the Vs. Okay, a simply sine wave, Vm sin omega t. Okay, so now capacitor is connected to this Vs, means it will charge up to the maximum value. So it is negative now. Okay, so it will charge like this and negatively increase the charge voltage and up to the maximum value, and it will hold that maximum value Vm. So means at the end of the negative half it will be holding a maximum value voltage Vm. Okay, it will be charging from here and will be charging up to the maximum and it will hold that maximum voltage Vm. Okay, so at the end of this negative half the voltage across the capacitor will be Vm, and during the positive half the condition is during the positive half here will be positive and here will be negative. So this diode will be reverse biased. Okay, it will not be conducting. Okay, so now this is not conducting, so R will be conducting. So it will be equivalent to a RC network. Again the capacitor is not now connected to Vs through a R, so it will be charging through RC network. So okay, so RC network will be linear. Okay, charging will be linear. Okay, so it will be charging like this. Capacitor will be charging like this, and at this point the voltage across the capacitor will be equal to the gate threshold voltage. So the capacitor voltage is connected to the gate. So so this capacitor voltage is connected to the gate. So this when the capacitor voltage reaches the gate threshold voltage, the thyristor will be turned on or will be fired. Okay, so the output voltage will be the Vs. Okay, now the output will be Vs, means the thyristor is firing at this point. Okay, so this time the charging time is depending upon the value of RC. This the time constant RC depending upon RC. So we can delay the this time. So we can achieve this triggering at this point if the charging is delayed. So if the time is delayed means it will be only triggered at this point. It will become VGT only at this point. So we can vary this by varying R. Okay, so now we can vary the alpha. So it will be varied. We can achieve the triggering here, or if R is increased means it will be slowly charging and will be triggered at this point. So at this point or this point, so we can attain a firing angle above 90 degree. Okay, so the firing angle is greater than 90 degree. So this is about R and RC triggering circuit. So in R triggering circuit, the firing angle is in between 0 to 90 only. We can achieve only a maximum value of firing angle as 90 degree. Here we can achieve the firing angle above 90 degree. So that is the advantage of RC triggering circuit above R triggering circuit. Okay, so with this we can wind up the session. Thank you.